everyone. This is Vijay Lakshmi Sugnali from Venmas YouTube channel. Venmas is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and various competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation well for so many competitive exams. Okay, here in this session, we discuss the miscellaneous problems on the concept sets. Okay, the first example here show that the set of letters needed to spell cataract and the set of letters needed to spell tract are equal. Okay, we have to show the two letters. One is cataract and another one is tract. Both are equal sets. Okay, now first I would like to consider first one letter cataract. Okay, that is let X be a of all letters, set of all letter from the word cataract. Okay, so I will written in a set form. Okay, that is first word is C, then letter A, P. A already I have written here. Next R. Again A I have written here. C also written T. Okay. Only those four letters are there in the set X. Okay. Similarly, I have to consider another one set Y. Let Y be a set of all letters. Set of all letters from the word track. Okay. Now I have to write the set Y. Okay. The letters I have written in a set form is T, R, A, C. T always, sorry, T is again written in first letter. Okay. Now X and Y are two sets. Now we have to check the equal. Okay. Equality of the sets. We know the definition of the equal set. According to the definition, what we say, if a set is said to be a equal set, if each element of both the sets are equal. Okay. Here I have considered X at containing the letter C, A, T, R and Y be a set containing the letters T, R, A, C. Okay. Now we have to check the letters. C, C, A, A, T, T, R, R. Okay. Both the sets having the same letter. That's why X and Y are equal sets. X and Y are equal sets. That is X is equal to Y. Okay. This is the solution of the given, or else it is the proof of the given example. Now consider the next example. Example number 24. List all the subsets of set containing the elements -1, 0, 1. Okay. Already we discussed the concept subsets in last session. Okay. The subsets means all the elements of the sets. Okay. Now, here there are three elements as we know about the concept power set. Okay. According to the power set, we can write P of n is equal to 2 to the power n. This power set can be applied for subsets also. Okay. Here there are three numbers are there. Sorry. Three elements are there in sets. Okay. Now I have replaced n by 3. 2 to the power 3. That is 2 into 2 into 2. When multiply these two numbers, we get 8. Okay. Now the concept is clear. There are 8 subsets are there. For this one set, we have to write the 8 subset. The first one subset is empty set. We know that empty set. Okay. Empty set is the subset of every set, as we know. Okay, 1. Then I will consider the single letters or a single elements as a set. -1, 0, 1. After that, take two numbers, -1, 0, 0, 1, and -1, 1. Finally, the whole set can be written here, -1, 0, 1. Okay. Now let me check. 1, 2, 3, 4, 5, 6, 7, 8. Okay. There are 8 subsets for the set here. Okay. Now let us move on the miscellaneous exercise problems on the concept of sets. Okay. The first one question is, decide among the following sets which sets are subsets of one another. Okay. We have to check the sets one by one for the sets A, B, C, D. After that, you have to check whether which one set is the main set and which one is the subset. Okay. Now, there is a first one set, A be a set containing the elements x such that x is belongs to R and x satisfies x square minus 8x plus 12 is equal to 0. Okay. Now, we have to write in a roster form. Okay. So while solving the equation, we have to write here x square minus 8x plus 12 is equal to 0. Okay. While solving the quadratic equation, we have to take the plus 12 number. When you multiply, you will get plus 2. Then when you add or subtract any two number, you get minus 8. Okay. 6 2s are 6 2s are 12. Here there is a plus 12. When you add 6 plus 2, you will get minus 8. This is minus 6 minus 6. Okay, minus 6 minus 2. When you multiply minus 6 minus 12, you will get plus 12. Again, when you add these two numbers, you will get minus 8. Okay, now I will take here x square minus, I will replace 8x by minus 6x minus 2x plus 12 is equal to 0. Balance the equation and make it as a two groups. So from this one group, I will take x as a common, x minus 6. Again take minus 2 as a common. This is x minus 6 is equal to 0. While solving this equation, x minus 6 equal to 0, x minus 2 equal to 0. Then x is equal to, take minus 6 on this side, it becomes plus 6. Here take minus 2 on this side, it becomes plus 2. While solving the equation, we will get the elements here, the set containing the elements A, that is 2, 6. The set A containing the elements 2, 6. Okay. Now, finally, the set of elements are A set containing the elements 2, 6, B set containing the elements 2, 4, 6, and C containing 2, 4, 6, 8 up to so on, and D containing the element 6. Now, we will check one by one. For set A. For set A, since all the elements of A are in B. Okay, here A containing 2, 6, these two numbers are present in B. Therefore, A is subset of B. Okay, again, since all the elements of A are in C. Okay, all the elements 2, 6 which is present in C. Okay, I will write here, since all the elements of A are in C. That's why A is subset of set C. Okay. Now again 2, 6. Here 6 is only present in D. but 2 is not there. That's why A is not a subset of B. Okay. Again, I will check for set B. Now, according to the set B containing the elements 2, 4, 6. Okay. While checking the A set, 4 is not present in A. That's why B is not a subset of A. While considering B and C, the elements of B which is present in set C. So, since all the elements of B, since all the elements of B are in C, therefore B is subset of set C. Okay, done. Nothing. C is the largest set. Okay, according to 4 sets, C is the largest set. Therefore, it is not a subset of any set. Okay, it is not a subset of any set. I will write here for set C. Since set since set C is the larger set. Since set C is the larger set, therefore it does not contain any subsets. Any subset. Okay. Again for set D. Set D containing the elements 6 only. While comparing all the sets, 6 is the only one element which is present in all 3 sets. Since all sets containing since all sets containing the element 6 containing the element of set D, therefore D is subset of A, again D is subset of B, then D is subset of C. Okay, now C is the main set and A is the subset of C and B. B is the subset of C. D is the subset of all the sets. Okay. Now let us move on the next question. Question number 2. In each of the following, determine whether the statement is true or false. If it is true, prove it. If it is false, give an example. Okay. Here I will take an example. Based on the example, I will prove the statement whether it is true or false. Okay. Here, according to the concept or else definition. Here, first one is if X is belongs to A, X be an element. Okay. X be an element which is belongs to set A. So I will take one element A be a set containing the elements 1, 2. Okay. Then I will take X is equal to 1. Okay. X be an element 1. Again, A is subset of B. It means B be a one set. It containing a set A. That is 1, 2 and some other elements 3, 4, 5. Okay. B be a set containing the elements 1, 2. It is a set 3, 4, 5. Okay. Then X be an element which is belongs to B. It is true? No. X is not a subset of B because X be an element which is containing the number 1. 1 is the element of set A. It means 1, 2 is the whole elements. It is not a particular element. That's why this is the false statement. Okay, this is the false statement. Because 1 is not an element of 1 comma 2, or else the main set 3 4 5. Okay, that is 1 is not the element of set B, not element of set B. Okay, therefore the statement is false. The statement is false. Okay, now we will discuss the second one. If A is a subset of B. Okay, A is subset of B means if all the elements of A are in B. All the elements of A are in B. So I will take A be a set containing an element 2. Okay, since A is subset of B, then B be a set containing the elements 0, 2. Okay, while using this one set from main set, I will write the set A. Okay, that's why 2 should be an element of set B. Hence, taking 0, 2. Also, this one statement is completed now. And B is an element. Here, this means it shows always elements. Okay, that's why I have written C be a set containing the elements B. Okay, the set B and sum of the elements 1, 3. Okay, the elements of 1, 3. Or else I will write here the set C is equal to 0, 2, 1, 3. Now, A be a set containing the element 2. Here, 2 is belongs to C? No. Since an element, since 2 does not belongs to the set 0, 2, 1, 3. That is, 2 is not element of set B. 2 is not a element of, here, set C. Therefore, the statement is false. The statement is false. Okay. Now, let us move on the next one. If A is a subset of B, again B is subset of C, then A is subset of C. Obviously, this is the true statement. Okay. So, I will prove generally. First, here A be a set containing an element 1. Okay. Because there is a symbol subset here. Okay. A is the small set, B is the main set. Main set containing the elements 1, 2. Okay. Again, B is the subset of C. Then C is the greater than B. So I will take elements 1, 2, 3. Okay. Both the statement is true now. After that, A is subset of C. Yes, because an element 1 is the subset of 1, 2, 3. Because this is the main set and this is the small set. Or else by using the main set, we can take the another one set. Since set containing an element 1 is subset of main set C. Since A is subset of C. Therefore, this is the true statement. This is true statement. Okay, let's move on to question number 4. If A is not subset of B and B is not a subset of C, then A is also not subset of C. Okay. If not subset means if both the set containing a different elements. If in case it both the set contain at least one different elements. Let us consider one example. A be a set containing the elements 1, 2. And again B be a set containing the elements 1, 3, 5. Okay. Here both the set containing different elements. Okay. Both the set containing different elements. That's why A is not a subset of. Okay. Now again let us consider another one set C. Okay. Set C containing the elements 1 to 6. Okay. The set containing the elements 1 to 6. Then while considering the set B. Okay. Since by the sets B is not a subset of C because B and C containing different elements. Okay. Now then again now I will check A be a set containing the elements 1, 2 and C be a set containing the elements 1 to 6. While observing the set A and C, according to this, A is a subset of C. But in statement, they given according to this, A is subset of C. Yes, this one is right. Since according to definition, this is not a true. Okay, that is all elements of set A, all elements of set A in all elements of set A in set C. Okay. Therefore, A is subset of C. That's why the statement, the given statement is false. The given statement is false. Okay. Now, I will consider the next one question. Question number 5. If X be an element which is belongs to set A. Okay. Again, A is subset, not subset of B. Then X is also element of B. Okay. First, I will take the one set A containing the elements 1, 3, 5. Okay. And X be an element. Okay. I will consider one element here, that is 5. I will take any, you will take any one element as a X here. No, I will take X be an element. I will take it as a 5. Again, A is not a subset of B means B is also containing different elements other than this set. For example, I will consider 0, 2 here. Okay. A be a set containing the elements 1, 3, 5 and B be a set containing 0, 2 by the condition A is not a subset of B. Okay. After that, an element X which is belongs to B? No. Okay. Because since element 5 does not belongs to set B. Okay. Since an element 5 does not belongs to B. So, the given statement is false. Okay. Now, let us move on the next one question. Question number 6. If A is a subset of B. Okay. If A is a subset of means B is the greater set containing the elements 1, 3, 6 and A be a set containing the elements that is 1. B be a set containing the elements 1, 3, 6 and A be a set containing 1. A is the subset of B. Now, X be an element which is not belongs to B. Okay. Here X be an element which is not belongs to B means I will take any one of the element here other than 1, 1, 3, 6. So X be an element, it is 2. Okay. X be an element, it is 2. Then here the element 2 is not belongs to the set B means it is also not a subset of A. Okay. That's why X is also X is does not belongs to A. So the given statement is false. When it is not element of set B means B is the main set and A is the smaller set. Okay. Then if it is not belongs to B means it is also not belongs to A only. Okay. That's why the given statement is sorry here the given statement is true. Okay. Sorry. The given statement is if it is not belongs to B means it is also not belongs to in A only. That's why the given statement is true. Now let us move on the question number 3. Let A, B and C be the sets such that A union B is equal to A union C and A intersection B is equal to A intersection C. Then have to show B is equal to C. Okay. Here in order to prove we have to prove here B is equal to C. Okay. B is equal to C means the set B containing the elements is equal to C. Means B and C are the equal set. Okay. Again, we have the given here A union B is equal to A union C. And also A intersection B is equal to A intersection C. It means B is subset of C or else and both C is the subset of B means both B and C containing the same elements. B is subset of C and C is also subset of B. Now let's consider an element X which is belongs to B. Okay. Now after that X be a element of B means it is also A union B. Okay. According to the statement or else according to the some properties what we written since A is a since B is the subset of the main set A means then it should be A union B is also A only. Okay. Here it is B. B is the subset of A union B. Means A union B means if an elements which is belongs to both A and B. That's why I will take both the elements of set A and B. Then the common elements have to written only once according to the definitions. Okay. All the elements of B is belongs to A union B only. Then X is belongs to A union C. Same since A union B is equal to A union C. We already know that B is equal to C means in place of C, I will take here C is also subset of A union B. That's why I have to take an A union B is equal to A union C. If according to this one, I have to write here union means X is belongs to A or X belongs to B. X belongs to A or X belongs to B. Union means it may be present in A set or else it may be present in set B. Okay. I will take this one statement as a 1 and this one is the 2. Again, I will take X belongs to A. This is equation number 3. Then X belongs to A means also an element X belongs to B only because of the definition A union B. Okay. Therefore, an element X belongs to A intersection B only. If it is both A and if it is both A and B also. Again, therefore, if X be an element which is belongs to B, then an element X which is belongs to inside C. If the an element X which is belongs to both, that's why B is subset of C only. Then if B is subset of C means again B is also subset of C. Now again taking an element X which is belongs to C. An element also X belongs to set B only. Then if X belongs to B, then X is belongs to C. Therefore, X belongs to B means then X is also belongs to C only. Again also B is the subset of C. Similarly, we have to prove C is subset of D. Okay. From it means X belongs to C or X belongs to B. Then from second and fourth, we say C is the subset of D is equal to B is the subset of C. Therefore, B is equal to C. This is the proof of the given result. Okay. First, we have to prove the set B is equal to C. Okay. After that, according to the definition, it means B is subset of C or else C is subset of B. We have to check both the result because when you take equal means according to the definition of equal set, both the sets having the same elements. That's why I will take all the result here. Okay. From this result, we have to prove B is equal to C. Next, show that the following 4 conditions are equivalent. Equivalent means each condition should be almost equal to their result. Okay. First one, while using the first one, I will prove both the first one and second one are the equivalent. Okay. Now, first statement I have considered, let A is subset of B means B is the main set, A is the smaller, or else both the set having the equivalence. It according to the definition, what we say according to definition, all the elements of all the elements A in B, all the elements are in B. So both elements are same means when you take difference. Okay. Both sets, while taking one example here, 1, 2, 3, and this is A set and this one is the B set containing the elements 1, 2, 3. Both are set containing the elements 1, 2, 3, 1, 2, 3. Then A is subset of B. According to this, while taking A minus B means, okay, the difference of sets. The difference of sets, according to the definition, difference of sets A minus B means while taking the common elements, first have to neglect it. While the common elements are neglected, then the elements present in set A is empty. Okay. In generally, I have written all the elements of A in B means A minus B should be null set. Okay. Therefore, A subset of B is equivalent. This symbol shows the equivalent A is subset of B. Okay. Now, again, second step. Consider the second statement. Let A minus B is equal to empty set. Okay. A minus B containing the elements. Empty set means there is no elements in both. There is no elements differ from B. There is no elements differ from B. Okay. There is no elements differ from B. That's why all the elements A in B, all the elements A in B. Okay, while observing this example, what I written, all the elements A in B. Therefore, all the elements in A means A union B is equal to B, or else A union B is equal to A. Both results are true. Okay. Now here the result 3-1 is necessity. I will consider this one. Therefore, A minus B is equal to null set is equivalent to A union B is equal to B. Statement 3. Again, statement 3 is equivalent to 4 only. If A union B is equal to B means all the elements A in B only. Both elements are same or common. Now, all the elements are common. All the elements are common. All the elements are common here. That's why A intersection B is equal to A only. Therefore, 3 is equivalent to A only. Okay. 3 is, therefore, it is equivalent to A intersection B is equal to A. Therefore, the statement 1 is equivalent to B. The statement 3 is equivalent to 4. Okay. Which statements are equivalent to each other. Next, question number 5. Show that if A is a subset of B, then C minus B is also subset of C minus A. Okay. We have to show that if A is a subset of B, then C minus B is subset of A. Now, I will take one example. Based on the example, I will show you. Let A be a subset. Okay. A is subset of B means A containing smaller than B. So, the elements of 1, 2. Again, B is the main set. So, it containing the elements of A also 1, 2, 3. Okay. Again, C. B a set containing the elements 1, 2, 3, 4. Now, I will check the result first. C minus B. Let consider the statements C minus B is subset of C minus A. I will consider the LHS part first. That is C minus B. Set C containing the elements 1, 2, 3, 4 minus B set containing the elements 1, 2, 3. Okay. Now, first have to neglect the common elements 1, 2, 3, 1, 2, 3. Then left, what are the elements? Only 4 is present. Okay. After that, I will consider the RHS part C minus A. Set C containing the elements 1, 2, 3, 4 minus 1, 2, because A set containing only 2 elements. First have to neglecting the common elements 1, 2, 1, 2. Then what are the elements? 3, 4. Okay. After that, the LHS part containing the elements 4 is the subset of 3, 4. Yes. Okay. Therefore, this is the C minus is subset of C minus A. This is the proof of the given problem. Question number 6. Show that for any sets A and B, A is equal to A intersection B union A minus B, and A union of B minus A is equal to A union B. Okay. Now I will take example. Based on the example, I will solve this one problem. Okay. Now here, first I will consider the example here. First, A be a set containing the elements 1, 2, 3, and B be a set containing the elements 2, 3, 5. Okay. Now I will take the first element. Set A is equal to A intersection B union of A minus B. Okay. I will consider the RHS part here. First, I want check A intersection B. Okay. A set containing the elements 1, 2, 3, and B set intersection B set containing the elements 2, 3, 5. What are the common elements here? 2, 3 is the common elements. Clear? Now, A minus B. What are the common elements? 2, 3. Other than the elements which is present in A is element 1. After that, A intersection B union of A minus B is equal to, okay, A intersection B containing the elements 2, 3, union of A minus B containing the elements 1. Okay, while writing in order, it becomes 1, 2, 3. So A set containing 1, 2, 3. Here the result is LHS. Therefore, LHS is equal to RHS. Okay, the first one is proved. Now, again, I will take the second one statement. A union B minus A is equal to A union B. Okay, first I will consider the LHS part here. In that LHS, B minus A. What are the elements of B? 2, 3, 5. And minus A containing 1, 2, 3. Okay, what are the common elements? 2, 3. The elements which is present in B are only 5 after neglecting common elements. Then A union B minus A. Okay, here A containing the elements 1, 2, 3, union of B is 5. So elements 1, 2, 3, 5. This is the LHS part. Now RHS part. That is A union B. What are the elements of A? 1, 2, 3. Union of what are the elements of B? 2, 3, 5. Okay. Now while taking the union, it becomes 1, 2, 3 and 5. Okay. While taking the LHS and RHS, both are E. Hence, both statements are true here. Next, let us move on the question number 7. Using the properties of sets, show that A union of A intersection B is equal to A only. Okay. Now, first one statement. First one statement. We have to prove A union A intersection B is equal to A. They given using properties. So we have to use only properties. They are not given properties means you have to prove by using examples only. Okay. They mention properties here. A union A intersection B. It means A union A intersection B is the subset of A. While equating the equation, first you have to consider subsets. It means A is subset of A and A intersection B is also subset of A according to the properties. So then what we written according to the property, what we written A is the subset of A union A intersection B. Okay. Again, as a set is a subset itself. Okay. It subset itself. Now, again, it is a subset itself. Also, A is a subset of A intersection B only. Okay. It means A is subset of A intersection B means A is belongs to A or else B as all elements of set A are in A intersection B only. Now A union A intersection B. Again using the distributive law. Again using distributive law. What we written? A union B intersection C can be written as A union B intersection A union C. Okay, A union B can be written as A intersection A union C can be written as A union B. Again, A union B can be written as A. A intersection A becomes A only. This is the RHS part. While taking the LHS part, we have to prove the RHS. Hence, A union A intersection B is equal to A only. Okay. Hence, this one is true. Second one, you have to prove only. Then, question number 8. Show that A intersection B is equal to A intersection need not imply B is equal to C. Okay. So I will consider one example here, simple example. A containing the elements 1, comma 2, B containing the elements 3, comma 4, C containing the elements 5, comma 6. Okay. Now LHS part, A intersection B. Okay, set A containing 1, comma 2, intersection B containing 3, comma 4. There is no common element. The result will be null set. Again RHS. A intersection C. A containing the elements 1, comma 2 and C containing 5, comma 6. Then there is no common elements, null set. While observing the result, LHS is equal to RHS. But B does not equal to C. Therefore, need not be equal. Okay, this is the proof of the given problem. Next, question number 9. Let A and B sets if A intersection X is equal to B intersection X will be null. Then A union X is equal to B union X for some set X. Show that A is equal to B. Okay. And the 10th one question will be find sets A, B and C such that A intersection B, B intersection C and A intersection C are non-empty sets. Non-empty sets means must and should the sets containing the elements, and A intersection B intersection C should be null set. Okay. Now you have to prove or you have to find both the results of the question number 9 and 10. After solving question number 9 and 10, you have to write answers in a comment box. If you really like my classes, please like, comment and share to your friends. And also press subscribe button and one like button. Okay. Thank you for watching my videos. Thank you everyone.